Today, we are going to talk about perfect square, Lesson 2. Revision from Lesson 1. The product of two consecutive positive integers is never a perfect square.
This means that 2018 multiplied with 2019 is not a perfect square. Since it is not a perfect square, we can ask the following question.
Question 1a. What is the smallest positive integer k so that 2018 multiplied by 2019 plus k is a perfect square?
The answer is 2019. This is the explanation. Note that 2018 multiplied with 2019 lies in between 2018 square and 2019 square. We wish to know that how far is this product from 2019 square, and the answer is 2019. We also can see the explanation from the mathematical expression above.
Another conclusion from Lesson 1 is the product of two positive integers a and a plus 2 is always 1 less than a perfect square, and it is never a perfect square.
This means that 2018 multiplied by 2020 is not a perfect square. Similarly, we can ask the following question.
Question 1b. What is the smallest positive integer k so that 2018 multiplied by 2020 plus k is a perfect square?
The answer is 1. Here is the explanation. The product of 2018 and 2020 lies in between 2018 multiplied by 2019 and 2019 square. We wish to know how far this product from 2019 square. Since we already know that the distance in between these two is 2019, and it's not difficult to know that the distance in between 2018 multiplied by 2019 and 2018 multiplied by 2020 is 2018, and hence the distance in between 2018 multiplied by 2020 and 2019 square is 1. This can be shown by the expression above. Alternatively, it can be shown by this explanation. Now we are ready to ask the brand new question for this lesson.
Question 2. Can the product of four consecutive positive integers be a perfect square?
Some examples of this product are 24, 120, 360, 840, 1680. Note that none of these is a perfect square. Here are some observations. 1 times 2 times 3 times 4 can be written as 1 times 4 multiplied with 2 times 3, which is equal to 4 times 6. Likewise, 2, 3, 4, 5 can be written as 2, 5, 3, 4, which equals to 10 times 12. And 3, 4, 5, 6 is equal to 18 times 20. And so on and so forth. Do you notice anything? Yes, you are right. The product of four consecutive positive integers is similar to the product of two positive integers a and a plus 2. So, what's your answer for this question? The answer is no. Obviously, since we know that the product of four consecutive positive integers is equal to the product of two positive integers a and a plus 2. Using the previous result, that this product is never a perfect square. Hence, the answer is follow. Now, how are we going to show this mathematically? It can be shown using the following expression. Now we can have our result for this lesson.
The result. The product of four consecutive positive integers is always 1 less than a perfect square, and it is never a perfect square.
We can rewritten this result as follows.
The product of four consecutive positive integers plus 1 is a perfect square.
Notice that 1 times 4 plus 1 is 5, 2 times 5 plus 1 is 11, 3 times 6 plus 1 is 19, and so on and so forth. But how are we going to show that this is always true for general case? It can be shown using the following expression. So here come to our last question for this lesson.
Question 3. Given that 100 multiplied by 101 multiplied by 102 multiplied by 103 plus 1 equals to k squared for some positive integer k, find the value of k.
And here come to our conclusion for the lesson.
The product of 4 consecutive positive integers plus 1 is a perfect square.
And it is similar to the following mathematical expression. We can generalize this result as follows. Suppose a and d are integers. The product of a plus d, a plus 2d, and a plus 3d plus d to the power of 4 is a perfect square. You may show this result by your own. Note that d equals 1 is for the case for consecutive positive integers.
Hope that you enjoyed the lesson. Thank you.
And bye bye.